So now in this video we're going to start with the actual circuit. I do have a diagram that we'll look at later. But in case, we have a light dependent resistor voltage divider right here. With my lamp, at the brightest setting we have a straight line, and at a dimmer setting we have a straight line. So that tells me that this lamp is actually lowering the amount of current that it's providing to the LEDs. There's a bunch of LEDs up there, and so you know it's probably giving us a steady voltage because the light is not changing very much. Now this is my older flashlight, and I'm going to shine it there. So at the brightest setting, yeah, there you can see it's jiggling. That's not me, you know, just shaking the flashlight a lot or something. If I set it to a lower setting, there you can see the jiggle's even wider right there. So what it's doing is turning off for longer periods of time, and that's actually the lamp, I think, keeping it up as high as it is. No, okay, it's actually the flashlight. So maybe they're not all turning off. It's not turning off completely. Oh, so yeah, that it does have a couple settings where it actually strobes the light, and there's one there, and then there's this one strobes too. And of course that's showing the actual strobe right there. That's not just it turning on and off rapidly enough to look more dim. So that's my older flashlight. Here's the newer one that I got, and so yeah, it's doing pretty good right there. So that's probably just a steady voltage being applied. We're getting the total brightness of the LED, and there you can see middle setting, it's jumping up and down. So that's definitely turning off rapidly. It looks like it's just on steadily to me, and same with this one. It's an even lower setting right there. I don't know how many all they got, and oh, it does have a flash as well. So this is actually flashing right there, and sorry if that's bugging your eyes. With these flashlights too, you should be able to hold it down for like a little more than a second or something. This one's not cooperating. I gotta keep hitting it till I turn it off. Sometimes you just hold it for a little longer, and then when you release it, it turns off. But it's not cooperating right there. So what we're gonna do is we're gonna overcome those problems with a capacitor right here. So first let me get, I can't trust the lamp. Yeah, that one's already like shaky. Let's get it even more shaky right there. I think that's kind of about how bad we'll get. So I'm not going to change what the flashlight does, but I am going to take the capacitor here and put it in parallel with the resistor. Resistor is going to the negative supply, and now the capacitor is. And what we are doing is we're getting basically kind of an average voltage now. But the main thing is we have a pretty steady voltage right there. So we could give this to a integrated circuit input, and it will probably be like either above or below whatever voltage it's waiting for, and hold it in place. Whereas without the capacitor right there, we could be bouncing, you know, I don't know how many times a second this is, above and below a point that might be switching what the integrated circuit does. It doesn't have like a specific light level that it's reading. Whereas now it probably does right there, even if it may take like a little bit of time to finally get to that leveled off spot. It's going to make its way there and stay there. Another thing I want to point out, I'm powering this with 5 volts. We did not see it get up to 5 volts. That would be way up there. I think that's because I got 2 volts for division there. So we got 2, 4, and then 5. And that's how high we were going, but I think we were actually getting 5 volts. Can I press that? Nope, that didn't do what I wanted it to. But I can change what channel this is. I think with that button, there we go, channel 1. We are making that selection. And now there's some arrow buttons. I'm going to go to the left. There we go. That lowered it to 1. And now that should be 1 volt. Let me get the flashlight pretty bright right there with the capacitor. Now you can see we are up 1, 2, 3. It looks like 4 squares right there. Looks like I might be able to get higher. Yeah, if I get it brighter. So the flashlight's just not bright enough yet. That's only a 1000 ohm resistor on the low side right there. Higher value resistor would get us a higher voltage at any given light level. So yeah, here's the diagram I got. Again, made it a long time ago. Don't know exactly why I picked a 47 microfarad capacitor there, but probably it wasn't a stiffen up voltage when I used a lower value capacitor there. Larger the value capacitor you go, the better it's going to hold a specific voltage. Of course, that voltage is going to change as the light level is going to change, but a larger value capacitor, it's going to take time to make its way to that voltage, which may be okay, may be perfectly okay. But in any case, otherwise, without a capacitor, as we saw, there's no capacitor there at all, and the light's not steady. It's getting brighter and darker, on and off completely, whatever it's doing. That voltage is going to be bouncing around. Whereas with the capacitor is going to be charging just a tiny bit and then discharging just a tiny bit, you know, many times. So the voltage is going to kind of like wiggle a little bit, but if you use a large enough value capacitor, it's going to be almost straight. But again, larger value capacitor is going to also take time to change. But maybe you're fine with that. Maybe you don't want it to change instantly if the light just kind of flickers something or really quick. You know, maybe you want that capacitor for that delay. So if you have a light dependent resistor, even though I don't show it in most of my circuits, you know, probably want a capacitor right there, you know, to help smooth out that voltage. And you'll definitely need it if the light is, you know, looks on to the naked eye because of how fast it's flashing. But circuitry like this will definitely detect that rapid change and pass that along. You'd rather have the average, kind of like your eyes are doing, averaging it out. So yeah, in any case, that's it for this video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help a lot. I'll see you in the next video.